Well, hey everybody, today is an interesting day. We are starting to progress again down our chapters. This time we are going to be in, again, chapter 2, but we are in section 5, literal equations. So chapter 2, section 5, and we're dealing with literal equations. Sometimes when you start to see these guys, we have to be careful, okay? It is very, very, very important that you're using the addition, subtraction property of equality, the multiplication, division property of equality. Also, in these particular ones, capitalization of your variables are super, super important. If you're working with an equation that has a capital letter, you better type that capital letter into your response or it will be marked wrong. A lot of times they also call this being able to rewrite equations. Okay, so different, how we have different equations for like length, area, volume, length times width equals 1/2 the base times the height equals the area of a triangle. All those kinds of things. We can solve for any piece of those equations that we want using this. This is probably up to date the most abstract of all of our lessons, and it can drive some students crazy. Don't worry, we're going to take our time on it. It is not meant, if you get this the first day, fantastic. We're probably spending 2 days on this, so you will have no problem whatsoever. All right, we have to take it piece by piece. I'm going to show you an example of each one clearly. In class, we'll be doing more examples, but at least you get to see an example of how they could ask each style of questions. All of these are simply going to be answered by moving pieces around from one side of the equal sign to the other. And what gives us the right to do that but our properties here, the subtraction, addition property of equality, multiplication, division property of equality. Look at our first example. It says solve for f. So I want to go ahead and box that variable that I am trying to solve for. So box the variable I'm trying to solve for. All right. Notice I included the sign. That's important. We have a w minus f equals capital B. Now, this w here and this f, they have addition and subtraction between them. So we have to draw our scales like we always do. Remember, the opposite of adding a w, we need to subtract w. So if we subtract w from one side, we have to subtract w from the other side. Notice is that w and b are not like terms. This is the most important thing we're going to have going on this entire section, is that almost nothing is ever a like term. So we can never recombine them together. All we're going to do is just rewrite. These w's here cancel, and we're left with a negative f equals capital B minus w. That's it. Notice these can't combine. We can't magically make a b minus w. All we can do is write b minus w. That's it. I'm going to clean up this. I don't like that negative sign. It was messy. All right, now we might be tempted to say, yay, we're done, but we're not. Okay, we are not done. Notice that we have a negative in front of this. So if we have a -1 being multiplied by this, we have to divide every piece, every single piece by a -1. So we need to make that negative disappear. So f is going to equal negative b. Notice the b is capitalized. Well, a minus w divided by a -1 becomes a positive w. That's the real trick in this one. And then this would be your final answer. Notice we didn't do very much math. What did we do? We used the addition, subtraction property of equality. Then we had to use the multiplication, division property of equality. And that gave us our answer. Now we have to look at the next one. This is solve for C. So we're trying to solve for C. C is locked in a numerator. So it's c divided by d equals mx. And we are stuck here. Well, we need to think about something here. How do we get rid of a denominator? Well, a denominator is what? Division. So the opposite of division is multiplication. And we should know by now, like if we wanted to cancel out 1/2, to make 1/2 go away, we would multiply it by 2 because these two cross multiply and they cancel out. So if I need to cancel out a denominator, just multiply by that denominator. And what I do to one side, I have to do to the other. All right, so here, look, the D's cancel, and I'm left with a C. C equals mx times d. And you're done. Something that looked super simple was really only one step. And what gave us the right to use that step? The multiplication, division property of equality. It's not too bad, right? I hope. Let's move on to the next one. This one here wants us to solve for v. So this time we're trying to get v over here all by itself. So again, before we can even do anything with the numerator, we're stuck in a fraction that has a denominator. We have to get rid of that denominator. Like we did in this problem, that's right. We are going to multiply by the denominator. If we do it to one side, we have to do it to the other side. Little n, capital M, now equals, these cancel, PVT. And what gave us this right? This was the multiplication division property of equality. Now we're still trying to get v by itself. So I am going to switch colors again so we can clearly see this. I need this v to be by itself. Notice I box it in. By doing that, it's letting me know I need all this other stuff to go away. Well, what? The p is being multiplied, the t is being multiplied. Just like in our other problems, the opposite of multiplication is division. So if I don't want a p and I don't want a t here, if I divide by a p and I divide by the t, I can get rid of them. Look, they cancel. All I'm left with is a v. Well, what I do to one side, I have to do to the other. Notice none of that can cancel. It's all different. So I'm left with little m over a capital M divided by a p t equals v. And like that, you're done. Again, this was the multiplication division property of equality that allowed us to do that. Notice this almost feels like trick math because we're not really doing much math. What we are doing is we're just following properties of math that give us a right to move a letter around. And it's just algebraically manipulating each one of these equations. This one here is interesting. It says solve for b. And notice something interesting. I have a b located in both terms. So we're going to have to use something that we may not have done before in the past. So I'm going to show you a little example right here, right? If we have 2 times x plus 1, right? Technically, we said that if we distribute this 2 to each piece, right? We have what? A 2x plus 2 times 1, right? Well, look what's happening here. We have a b that's being multiplied by each piece. So I can say that each of these pieces have a common, they're both multiples, right? Like they have a common multiple between these. They have a b, a common b. I can say because each of these have a b, first thing I can do is like I can say I can pull a b out of each of these, because I can't have two variables on one side of an equation, and I can't combine these two right now because t is different than m. I can't suddenly make it a TMB combination, right? So what I have to do is I have to be able to say, how can I rewrite this legally with only one b? And what I can do is I can factor this b out. Like this here, like this distributing spreads this 2 to each piece. If I want to pull that 2 back out, I want to undo distributing, we can do that. Remember, I told you that sometime in this year, we were going to teach you how to undo distributing. Again, we said distributing was a form of multiplication. So factoring is simply a form of division, where you're going to form a little set of parentheses. We said b is the common multiple, so you write it outside. And now you divide each piece by b. These get divided by b, you're left with a t. This gets divided by b, you're left with a minus m. I'm telling you, that's the hardest part because it's the new part. But look what it does. Knowing this trick, now how many b's do we have? If I said that I need to come here and I need to solve for b, sure, I got this. I'm going to change color so we can see it. I need to solve for b, right? Here's my one sole variable. I can do that. B is being multiplied by all this. So to undo multiplication, I can divide by the entire thing. I can divide by that whole thing. If I divide that side, I divide this side, right? That's the way it works. This is the multiplication division property of equality. What I divide one thing by, I can divide both things by. This all cancels on this side and leaves me with just b. And on this side, I just have to rewrite it all. Little qs, that's q times s divided by t minus m. And like that, this problem that would have been super duper 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 hard looking at it like this, just by learning how to factor, because that's what we used here, we factored. We factored this and managed to make it where it was nice and easy for us to just divide by all this other stuff. All right, last one here. This one says solve for capital B. It says be careful. Get it? Boom, boom, B, be careful. Yeah, we're solving for B. So notice we have a B on both sides. I need B to be all by itself, right? So I need to pick one side or the other to get rid of B from. I'm going to pick this side first here because it's being multiplied, right? So the rule says the multiplication division rule of equality tells me I can what? I'm allowed to divide. I know they're being multiplied. If I divide by B, these two are going to cancel, right? Draw my scales. I want to keep this constant. And if I divide one piece by B, I have to divide each piece on the other side by B as well. These are going to cancel on me. And I'm left with a C over B plus X equals 7. That's it. Now, clearly, I'm going to have some more steps to go. Trying to change colors. This doesn't want to cooperate. All right, it's all right. We got this color now. So we did all this work with this, right? We used the division multiplication property of equality. We divided B's, but it still left us with a B. So we have to circle this, right? Because our B is trapped over here. We can't move this B until we get rid of this piece. Well, if we have a positive x, the addition subtraction property of equality tells us that if we want to get rid of a positive b, the opposite is subtraction. We do it to one side, we have to do it to the other. Notice that 7 and x are not common terms. They cannot be added together. All we can do is just rewrite them. 7 minus x equals c over d. Now look, now we can finally try to tackle this b, right? This is one of the ones that's slightly confusing because it seems like you're moving the b all over the place. This b cannot stay here. It cannot stay in the denominator. We need this. We have to have this go away. So in order to make c go away, we can't make it move. The only thing we can do is make the b move. So we have to, again, while it doesn't seem like it's a necessary step, we have to make that b move to the other side. It's stuck in the denominator. So the only thing you can do to get rid of the denominator is multiply. Because this is division, that's the opposite of it. We multiply. We did this in one of our other ones up above. Now, if we multiply this side by it, we have to multiply this side by b as well. Notice how I wrapped it in a set of parentheses, because now that we multiplied the b here, it's not being multiplied to one piece, it has to be multiplied to each piece. We don't want to do it to each piece, we want to just keep it by itself like we did in the last problem, because it's easier to tackle. So now we have to rewrite again, and I'm going to have to move over here to this side because I'm almost out of space. So rewrite the problem one more time. Notice these b's cancel, and now we just have c. So we have a b I promise we're almost done with this problem, and I know your brains hurt just thinking about all this abstract math. But you'll do a few of the easy ones today. It'll soak in. Tomorrow we'll come back and we'll do a lot more of the hard ones. All right, b needs to be by itself. We need this b to be all by itself. And in order to do that, we are going to have to do another move to it. Okay, again, what b, we change colors. B is being multiplied by this 7 minus x. So the opposite of multiplication is division. I want this whole piece here to move, so I can divide by the whole thing, 7 minus x. If I divide one side by it, I have to divide the other side by it as well. Okay, these will cancel, and it leaves me with just that capital B. And then this entire thing, nothing can be done to it, so we carry it down. C divided by 7 minus x. So B equals C divided by 7 minus x. I know it seems so crazy, guys, that we are doing all this manipulating, all this moving of all of these abstract concepts. But that is what literal equations is. It's literally a pain in your head. It's a big headache sometimes. But all we've done is, look, what did we use here? This was the multiplication division property of equality. Multiplication division property of equality. The addition subtraction property of equality. We use 3 properties to legally move around pieces. The pieces cannot be created, added, nothing. It's just legally moving them around using the properties that we've learned. And when we do that, we end up just rearranging the original equation. This formula here is identical to this one, this original one. The only difference is it's solved for a different variable. And that is all that we have to do for this. All right. Get started on the homework, guys. I am not expecting you to finish all the homework today. This is a 2-part lesson. We do not want to try to do this all in one day. You need to let your brain have a rest or a brain break between trying to do this. It will melt your brain if you try to do it too much. All right. Have a wonderful day, guys. Enjoy that homework.